Hello everyone, in today's video we're going to be continuing our series on Python, and we're going to be taking a look at variable arithmetic. This is when we're going to be doing some basic mathematical operators to all those fun variables that we've been basically playing with over the last few videos here. So what we're going to do is create ourselves a list of some really simple variables here and sort of go through. The first one we're going to take a look at is going to be addition, and we're going to go show you what happens when you do addition to the various different types of variables. So let's go ahead and create ourselves a couple really basic variables. We'll do num1 is 5, we'll do num2 equals 10, just to keep it kind of simple. So we have two different variables here. Both of these are going to be integer variables, if you remember from last time, because we have no decimal here, and we're going to add them up. So what I'm going to do is create a new variable called sum and simply say num1 plus num2. Now the addition modifier is basically going to go ahead and add these two together, and then it's going to assign it to the variable of sum. Now if we were to go ahead and print sum, I'll come in here and type in print sum. If I were to run my code here, you will observe that it gives us a value of 15. Now there's a couple other things you probably want to observe with this particular value. One thing you'll probably observe here is not only is it 15, but it's the integer 15. There's no decimals basically chilling off the back here. And the reason that's going to get important is we'll see in a minute. You'll know what I mean when we come to it. There's actually a thing, we'll get there. I don't want to spoil the fun. So this is addition. I'm going to go ahead and leave myself another note here. Adding integers. Again, pretty straightforward, integers. Now, some people say can you add more? Could I do plus 5, 10 here? And I'll go ahead and run your code. The answer is yes. You can basically chain this thing together as far as you want with as many additions as you want. And you can go pretty hard on that if that's something that you like to do. And again, whenever we're doing any addition, it's just going to be plus. So watch what happens now if we want to add booleans. Now, let's say I create a B1. We'll keep it nice and simple. Bool1 equals true. And we'll say bool2 equals false. So if I try to add these together, one of the cool things we can do here is we can reuse sum if we want to be lazy. So I'm going to go ahead and say again, sum equals bool1 plus bool2, and we'll go ahead and print sum. Now you're sitting here going, if you add true and false together, what happens? You get 1. Yes, you end up with an integer when you attempt to add two booleans. And you're sitting here going, well, what if I add false plus false? If we were to go back and run it again, you will notice we get 0. And now adding booleans is a little weird, and basically could be a whole video series in and of itself because it gets a little complicated. This is definitely something we're going to take a look at a little bit later on, but I just wanted to throw it in there for the sake of being complete, just so you're mindful of what kind of goofiness that you're going to get if you accidentally try to do plus num1. So if we want to be really goofy here, I can actually come here and put num2 in here. So we're adding a boolean to an integer. What's that going to do? Well, you're going to get this handy thing that says 10, and you're going to go, what? Just be mindful of that. It does allow you to do things like that, even though that doesn't necessarily make any sense at all. So I would almost say ban this from your memory here. Be very careful with stuff like that. So let's get a little more complicated. Let's add floats. If you remember from a few times ago, a float is going to be a decimal. So I'm going to go ahead and say float 1, and I'm going to set it to a value of 0.1. I'm going to say float 2 and add it to a value of 0.2. So we're going to use my sum again. We're allowed to do that in Python. It's called polymorphism. I'm allowed to cheat like that. So let's add float 1 plus float 2, and let's print sum. Let's see what happens this time. Now this is interesting. Go ahead and press sum, and you'll observe that 0.1 plus 0.2, as everybody knows, is 0.304. And your brain is going, no, it ain't. It's 0.3. Aha! Welcome to floating point errors. So as I mentioned many videos ago, or a few videos ago, variables are stored in memory in specific ways. There's only so much you can do with that memory before you're like, that's good enough. When it comes to floats, you'll observe here that good enough is about that many decimals. Past that point, we stop caring, and we have to get rather creative. Of course, there's very fun ways to kind of get around this problem, but it is a common issue whenever you're dealing with floats. Now, if you're dealing with money, you're probably dealing with a lot of floats because obviously 15 cents, 25 cents, and this becomes very complicated. It becomes something that you desperately want to be able to use. So you just have to be very mindful of that and be careful when you round, how you round, when to round. And there's actually a whole Python library called the decimal library, which helps kind of alleviate some of the issues you might encounter when you'd be dealing with these kind of floating point errors. Just so be kind of mindful of that. We're going to deal with this problem a little bit later on. Now, what happens when you add floats to integers? Now, one of the nice things is Python, unlike Java, is going to be smart enough to handle this one. So for example, if I want to go back to my sum here, sum equals float 1, which if you remember is 0.1, and num1 is going to be 5. Now, if I add these two together and print them, I expect, you can see 5.1. That makes sense. What I've done here is I've taken a float, added it to an integer, and my result is a float. Now, this is an important problem that you're going to have later on when you take integers and you divide them or you whack them with decimals. They'll automatically convert over to floats so that you get a result that actually makes mathematical sense, which is actually pretty cool. A lot of programming languages don't do that, so I don't mind at all the fact that it takes the time to do that. Like I was warning me that I've assigned the thing like 1,000 times, but don't worry about that too much. So now one more thing we can, of course, add is going to be strings. This is kind of an interesting thing we can do too. Add strings. So if I want to say string, I'll keep string 1 equals high, and I say string 2 equals there, and I print, I can get sum equals string 1 plus string 2. You're saying, no, you can't add those together. That would be scandalous. Oh yeah? Watch this. Run. You'll observe that it says high there. Now you're sitting there going, oh man, what happened to my space? How do I fix that? Well, if we wanted to, we could technically add another space in there. We could do plus quote plus. I don't put a space there, plus. And what this would do is this would take string 1, which says hi, put a blank spot. Again, we can add quotes. We're allowed to do that. And then go ahead and say there. So if I were to run this again, what you'll observe is it actually gives me a nice little break between the hi and the there. Now, some of you, of course, are sitting there going, that doesn't make any sense. Why don't I just say print string 1 comma string 2 in here? That solves the space problem. You certainly could. But again, the purpose here is to show you how to add things. Now, one of the interesting things about strings is strings do not play nicely with other variable types. This is actually one of the challenges a lot of people have when they're coming over, when they forget that you have to still convert them. So let's go ahead and create a new one. I'll do sum equals, let's see here, float 1 plus string 1, print sum. Now your brain is going, so this would take float 1, which if you recall is 0.1, and add it to string 1. So we should see 0.1 high is what your brain tells you. When I run it, we get a very angry error, and it's going to tell us unsupported operand type addition between a float and a string. We're not allowed to do that. We can't do that. If we try to add a number and a string together, one of them's got to change. Obviously, we can convert the string into a number, assuming it's a number, but it's not, it's high in there. Or we could try to convert that float into a string, then we would be able to actually add those together. That's something we'll deal with in a few moments. But as you can see here, again, strings are their own beast. Now you're saying, well, what if we made this that bool value? The Boolean, what would that do? You will notice nothing. It'll just say string because you're basically saying it is true. Hi there. There is nothing to see with that actual Boolean there. So it's just one of those kind of things that you have to be very mindful of. The next operator we're going to take a look at is going to be subtraction. But before we do that, we'll go to that. We'll go right to subtraction. Subtraction is a relatively easy controller too. Again, it's the exact same method as you saw before. So for example, if I wanted to say diff, as in difference, subtracting, I'll go ahead and do this. If I wanted to just go ahead and use diff for difference, I could go back to that original integer that I created. What did I call that? Num1, I think. Num1 minus num2, and I could print diff. Now, what you'll observe here is this works exactly the same way. Open this sucker up. Oh, forgot to fix this. String 2. String 2. There we go. Let's go ahead and fix up my own code here. There we go. You'll see that it has no difficulty going ahead in printing this sucker. You can see that we basically have ourselves a -5, which makes sense because basically +5 minus 10 is going to be that one. So that works actually pretty well. I'll call this one integers. So there's other things we can do too. Again, going to floats, subtracting floats. Subtracting floats. Again, keep it nice and simple here. What do we call it? Float 2 minus float 1. And what you'll observe here is something similar to what we saw a few moments ago. If I were to actually run that code, you will see that we didn't get that funky little decimal that we got earlier. That is just the nature of floating point math, basically arithmetic. Now, there's not a lot that we can do about it. Now, I'm going to skip doing any subtraction with Booleans for obvious reasons here. But watch what happens when we try to subtract strings. Your brain is going, ho, here it comes. Diff equals string 2 minus string 1. Let's see what happens when we try this one. I'll go ahead and run that sucker. And it's going to explode because we're not allowed to subtract two strings from each other. Now, professionals here would say, why am I talking to you? But a pro here would say, well, actually, you could split the two strings apart from each other, but that requires substrings, and that is way beyond what we're going to be getting into today. We're going to be much more interested at this point in just showing you kind of the basics. So that's going to be kind of this piece. I'm actually just going to delete this. Does not work, but you can see we're already on line 50 here. So we're cruising along quite nicely for this particular purpose. Now, of course, when we're doing all that other operations, you're sitting there, what about multiplication? What about division? They work basically the same way. And just for our purposes, I'm going to try to keep it just the numbers. So for example, let's say I want to multiply a integer and a float. So let's say, that would be a product. So I say prod, why not? Equals, we'll do float1 times, I should have called it int1. That would have been smarter on my part. Num1. So we'll go ahead and print prod here. And now if I run this, what you'll observe is we end up with a decimal. We end up with a float. So that's exactly what we want. Now, if we multiply two integers together, we'll go ahead and num2 here and keep it nice and simple. If I were to run that one, you will notice we end up with an integer. Remember, whenever something gets a decimal, it will auto-convert the result to a float. Otherwise, we'd have other issues that would kind of go along with it. Now, you're sitting here going, can you multiply two strings together? Oh, why do you have to ask? Multiply two strings. Oh boy, you had to ask. You always do those questions. Let's do string 1 times string 2. Print prod. I think you know exactly where this is going to go. I press the run key, and of course it explodes. It says, you can't do that. So what if I did times 2? Aha! Yes, you can multiply strings. You can actually multiply them by integers if you want to recreate multiple versions of the same string. This is one of those things people didn't realize you could do in Python, which I don't know, puts a smile on my face every time. But if I run ha 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 ha, you can actually multiply strings, and the resulting string will basically be a of whatever you actually multiplied there. And of course, just sitting here going, haha, as long as it's not two strings, it's okay. A string and an integer, totally okay if you want to be one of those people who wants to do this. Like I said, there's a lot of fun uses for this, but I think I've confused everybody quite thoroughly so far today, so I'm not going to do that too much. Division is where things start to get interesting. I'm actually going to go ahead and create myself a little divider. Division stuff. The reason I'm doing this is because division starts to get funky. As a programmer, one of the things we always try to avoid is dividing by 0. So if I said, oops, and I did 5 divided by 0, and I go ahead and run my code, you will notice nothing bad happens. Python has kind of this nice little built-in stuff. As a matter of fact, if I came in here and I printed oops, what you'll see here at the bottom is it'll not print anything. It's like, are you kidding me? And it basically exits. And again, if we want to try to go past this point, print, yup. Again, I'm just tossing this so we have an endpoint there so you can see it. You'll notice we got this lovely little exit code 1 here. And exit code 1 means you blew up. And you can actually see here that oops was the reason that we blew up. So again, you want to be very careful with dividing by 0. So what a lot of programmers will do is they'll never divide if they can help it. They'll always multiply by, especially fractions, or they'll multiply by decimals as a desperate. If I want to divide something by 2, I can say value equals 10 times 0.5. That's the mathematical equivalent of dividing by 2 because I'm multiplying by a decimal. That's kind of how we get around that. I mean, of course, you're sitting there going, if I want 10 divided by 2, I'm going to divide 10 by 2. Don't make this complicated for me. But again, remember, you can have all that other fun stuff that's going to get into here. So when it comes to division, division is relatively straightforward. So if I said we'll do quotient here, quat, and we'll go ahead and keep it simple for start. We'll go ahead and divide our first number there, our integer, divided by our lovely little float here, and we'll print quat. Sounds like someone makes starships or something. You'll notice we don't have an error, and you'll also notice that it did the division perfect. And because we're dealing in floats, you'll observe that it was smart enough to recognize that we're going to be dealing with a float as a result. Again, Python does that really well. Other languages would be extremely grumpy that I tried to do something like that. Now, it gets a little weird. Let me show you why. Let's say I want my quotient to be 5 divided by 2. Now, if I run this, your brain says 2.5. And you'll notice here, we started with integers. We ended with a float. Remember, floats are more expensive here. So we do end up, it is smart enough to know that we do need a decimal here. We'd have to actually get a little more complicated if we wanted to get rid of that decimal, but that's something we're going to be dealing with in a moment. So you can see that works pretty well. And no, I'm not going to do Booleans. No, I'm not going to do strings. You can't divide a string by 2. We can multiply strings, which I find personally hilarious. It's just kind of one of those things that nobody knew you could do in Python, but you can. But again, we're not going to do any of that stuff. But instead, I'm going to show you the other 2 flavors of division that you might not have as much experience with. The first one, of course, is going to be called integer division. So I'm going to do myself a little hashtag integer division. Again, I could do an entire video on this one, but for today's being thorough, I'm going to make sure you kind of have all the different operators in one place. And there are plenty other operators, and we'll deal with that a little later on, probably in the next video too. So integer division gives us the ability to divide things and have the result not have a decimal. For example, let's say I said, I'll call this a div. I'll just keep it easy here. Let's take 20 divided by 3. Now I'm going to print div. Now, experts, of course, know we're going to end up with a float here, and we're going to get all these funky decimals. And it actually did a really nice job. It rounded up on that last little bit there to try to keep some precision in our calculation. But let's say I just wanted the 6 from this calculation. Now, if we come up here where my little division sign is, if I put an extra divider here, you will now be getting just the integer quantity of this quotient. Now, if I come up here and press run, what you'll observe is I get a number 6. Your brain goes, 20 divided by 3 is not 6, Chief. Yes, but the part before the decimal is 6. Now, you're sitting here going, okay, well, that's pretty cool. What would we ever need that for? Well, one of my favorite things to do with integer division is to get decimals free, and it's a fantastic way to get decimals free. For example here, how many times? How many circles? How many complete circles did we spin? I'll say degrees equals blah, blah, blah. Oh, we have the U in there somewhere. Blah, blah. Wow, that's kind of complicated. So what I want to do is find out how many times we spun. So this is the total number of degrees. It should technically be total degrees if I want it to be a little bit more accurate here. But hey, this is for science. So what I'm going to do is I'm going to say total circles equals degrees / 360. And you're sitting here going, well, I digress. But I digress. What you're saying here is how many times did it go around in the circle? Well, we don't care about the decimal. We only want complete circles. So if we take our total number of degrees and do integer division on it by 360, that will get us our result. Now, if we want it to be professionals, the total number of circles is, squiggly bracket, total circles. Now, if I run this, check this out. That's how many complete circles we made. Kind of cool, huh? The other option we have, of course, is something called modulus, depending on what you want. That does the opposite. Instead of giving us the actual value, it's going to give us the remainder. Watch this. Modulo. I love modulo. It's fantastic. So what I'm going to do is I'm going to say mod equals 20 divided by 3. But instead of using divided by, I'm going to use a % sign, and I'm going to print mod. Now, let's figure this out before we go ahead and take a look at our output here. What you're going to observe is if we take 20 divided by 3, we get 6. 6 times 3 is 18. To get to 20, we need 2 more. So it would be 16 remainder 2. That makes no sense. 6 remainder 2. 16 is kind of fun. Also, 18 plus 2 is 20. Yeah, we're good. This, of course, would give us a value of, like I said, 6 remainder 2. Modulo will give us just the remainder. So if I actually run this, what you'll observe here is this gives us the number 2 because that's the remainder we need to get up to the next value. Now you're sitting here going, that's actually pretty handy. What could I use that for? Is that something I could do? Well, one of my favorite uses of modulo is to determine if something is even. Because if I take 20 modulo 2, that's going to be 10 remainder 0. If I run my code here, you will see that I get 0 as my result because there is no remainder. That also tells us that there's no decimal, which also tells us that 2 goes into 20 evenly with no decimal, making it a very, very, very helpful function that we can use in many, many different ways. Now, as you've seen, there's a lot of different ways and different types of math that we can do for different parts of variables. And again, we can see this is just a preview of all the craziness that we can do. Where things get really, really chaotic is when you start having to deal with order of operations. But that is something we will deal with in another video. Enjoy.